Alright, you guys, I threw together a couple problems off Big Ideas to try to show you some sample problems for 10.5 homework on learning how to graph secant and cosecant. So let's take a look. Just remember that these are tied so closely to sine and cosine curves. Because cosecant is 1 over sine, it is tied very closely to the sine curve, and a lot of the steps, beginning steps, are going to be the same, and a lot of the same things, same reference points. Alright, so let's take a look here. I'm graphing cosecant of pi force x. So what is that pi force going to affect my graph? Well, that right now is my b value. And what does b affect? It affects my period. It's that horizontal stretch or compression. And I know for cosecant it's the same as sine and cosine, that it is 2 pi divided by b. So if b is pi force, I'm going to take 2 pi and divide it by pi force, and that actually gives me 8 pi. If you do copy dot flip, oh, not 8 pi, my bad, the pi's are going to cancel, just 8. The answer is just 8. So I have a period of 8. So let's go take a look at some of these graphs and see which ones have a period of 8. So if I look at this first one, where does it complete one full cycle before it starts to repeat? Well, to me, that looks like it has a period of 2. Let's take a look at this one. This one goes, whoa, I'm not sure what happened there. From here to here. Oh, that's looking good. That has a period of 8, right? Okay, let's take a look down here in the bottom left. It's going from here to here. That's looking like a period of 8. And what about this bottom right one? Not looking good. That one is a period of 2. So the ones that have period 2, have had a compression, right? We don't want that. This pi force is actually going to stretch it. Does that make sense? We're actually going to be stretching that. Alright, so let's take a look. So we've got a period of 8, and let's see how those two graphs differ. So this one's definitely out and this one's out. So how do these two differ? Well, I see a really major point, and that is where the key points occur on each of those graphs, kind of that apex of that curve. Alright, so take a look at those. If I look at the top right, where does that line up? If you were to look and see what value does it line up with, well, it lines up with 1 and negative 1. Alright, what about this one down here? It looks like it's lining up with, golly, what do you think that is? A half maybe, or a fourth, 1/2, or 1/4, and negative 1/4, probably about that. So what affects the distance there? Well, what affects that is my A value. And you guys, what is my A value over here? The A is 1. The number right here out in front, the A value is 1, which means the correct graph is going to be this one right here, because it has an A value of 1. From its center line, it's up and down exactly 1 unit. Alright, let's take a look at another one. Practice makes perfect, right? Okay, this next one says, identify the graph g of x equals 2 cosecant x. Okay, this time, what am I given? I'm given this 2 out in front. And what did we decide 2 affects? That's right, it's the distance from my center line. So take a look at this first graph, okay? If this is my center line right here, then I should be up 2 units and down 2 units, and there shouldn't be any graph in between those two lines. So therefore, that one's out. He does not work. Maybe I'll mark that in red so you can see the difference. He's out. How about that? Alright, let's switch back to yellow. Let's take a look at the next one. So using the same thing, what does that 2 mean for secant, cosecant? It means the distance from my center line. So if this is my center line, I should be up 2 and down 2 without any graph in between there. Alright, clearly, he's out. Alright, the bottom left. Let's take a look at that one. I should be from my center line up 2 and down 2. Okay, that one's looking good. And what about this one, the bottom right? I should be up 2 and down 2 from that center line. Alright, these are both possibilities. Now, one of them looks like it's been compressed, right? So we need to determine which one's the correct one. Did I have any shifts, or not shifts, excuse me, any compressions in a horizontal direction or any stretches. That's determined by b. We use b for the period. For cosecant, my period is 2 pi divided by b. And in this case, b is 1, so my period is 2 pi. So which one of these does a full complete cycle in a length of 2 pi? Well, let's take a look at the bottom left one. Where does it do a complete cycle? Well, if I go from negative pi to positive pi, that's one complete cycle of the cosecant graph. And from negative pi to pi, that means I have a period of 2 pi right here. That one's going to be my winner. Why does the other graph not work? Well, go look at it. Where is one complete cycle? From 0 to pi, so it's telling me its period is pi. Therefore, that one is going to be out, and this one is the winner. All right, I got another one here. Again, practice, practice, practice. We just got to keep practicing, you guys. All right, what am I given here? All right, I have an a value of 1/2 and a b value of pi. We're going to use both of those numbers. So let's start out with my a, 1/2. Remember what that means? On the graph from my center line, so let's look at this one. If this is my center line, I should only be up 1/2 and down 1/2. Whoops, not very straight. And when I say that, what I'm saying is each of these where the curve, the apex of the curve, if you will, whatever you want to call that, those should be lying on my yellow line. And they're not. They're too far away from it. So he's out. Okay, so let's go take a look at the next one. From my center line, I should only be up 1/2 and down 1/2. Okay, same thing. They're too far away. That one's out. Okay, let's look at the next one. This one, once again, should be going up 1/2 and down 1/2. Good golly, he's way too far away. He's out. All right, well, we already know our answer, but let's prove it. Are you ready? We're going to prove it. Okay, I should be up 1/2 and down 1/2. Do you see that? And look at those. They're touching. Those key points are touching right there on the line. That is what I want to see. All right, just to prove to you that the other works, what do I do with this pi? That's my b value, right? And if b is equal to pi, that means my period, which for secant is equal to 2 pi over the b value. Okay, what was b? B was equal to pi. So that means my period is 2. Let's go double check. That graph down there, does it have a period of 2? All right, well, let's take a look. I'm going to need another color here. Let's go purple. All right, one complete cycle. Take a look, you guys. From -1 to +1, can you see that it completes one full cycle? I know it does like a half. It does this half over here, and then a full, and then a half. But that's still one complete cycle, which means it has a period of what? Of 2. It has a period of 2. That's exactly what I was looking for. Winner, winner, chicken dinner. He's the one. Okay, last problem. Hang in there, you guys. I thought you could use an example of graphing this from start to finish on your own. Okay, not a multiple choice, choose the correct graph, but can you graph this from start to finish? So just like every other one, I go through my steps. What's my a value? 1/2. Now remember, that's how far from the center line, above and below, I want my graph to start. My b value is pi. Okay, what does b do for me? It tells me that my period, which is 2 pi divided by b, that is a 2 there, sorry. So 2 pi divided by pi makes what? Makes 2. So it's going to have a period of 2. What is my c value? 0, so there's no left or right shift. D value, it's 0, there's no left or right shift. Not on this one. Okay, so I draw my axes. Okay, I have a period of 2, so I'm going to go out to 2. There's not a shift left or right, so I can stick right here. I'm going to go in half and half again to get those interval lengths so I can get those key points. All right, I know that I'm going to be going up 1/2, that's a 0.5 there, you guys, and down 1/2, down to, this pen just doesn't do decimals very good, to -0.5. That's bothering me. Let's fix that. That's a... maybe I can make a point. Well, you guys may have to live with it, just knowing that that's a 0.5 there. I tried several times to fix it. Just won't work for me. Alright, so that's going to be how I'm going to start my graph. Now I know that I'm going to have, oh sorry you guys, I know that secant, the graph of secant is always what? 1 over cosine. And where does cosine start on the graph? It always starts at, that's right, up 1. It doesn't start at 0, 0, that's sine. So for this one, I am going to be starting, I'm going to change my color real quick, hang in there you guys. So that means for this one, I'm going to start up here, up 0.5, and then I alternate down, down, back up, and back up. So when we graph secant, go back and think about your sine and cosine, the ones that they relate to, okay? It relates to that, and all I have to do is everywhere it touches at my middle line, that's where my asymptotes are. And then the other points, okay, that hit that distance from the midline or from the center line, that's where my curves are going to be. That's where I get these key points that I'm using. Okay, they're the same key points I use for cosine. I just now turn the graph to make these little loops. All right, good luck you guys. You've got this. Keep working hard and make sure you get caught up and finish so you can have a really awesome spring break. Enjoy that next week, all right? See ya.